remember what average looked at?
No, I don't know what the average was. And I've only graded your class, so I still have, 60 more papers to grade. So, all right. So here we go, folks. Here we go. This is our task. We've got 2 sections we need to get through. There are 2 big ideas: solving triangles, finding area. That's all this is about. It's very cut and dry. With the identities, some of you struggled because you had to be a little creative, you had to think, you had to put things together. This is not that. We have 2 laws. We have the law of sines, we have the law of cosines, and then we have some area formulas. That's it. I mean, it is so easy. It will go very, very fast. So 5.5 and 5.6 will go very, very fast. We'll have a quest next week over this material. It is not hard. Just pay attention today and you'll see what I'm talking about. So the directions say solve the triangle. And let's say we're given 58 degrees and 49 degrees and 16. We're going to solve the triangle. Now, we know triangles have 6 parts, 3 angles, and 3 sides. You will always be given 3 of those parts. So you were given 2 angles and 1 side. Now, there's something, you've done this kind of problem before. We did it in chapter 4. But it's a little bit different now because what do you notice about your triangle? It's not a right triangle. Now what does that mean? That means all the tools that you've been using, SOHCAHTOA, Pythagorean theorem, all that stuff you can't use. SOHCAHTOA relies on a hypotenuse, opposite over hypotenuse. If you don't have a right triangle, you can't use any of that. So our job is to somehow find angle C, side B, and side C using something other than the things we already know, the Pythagorean theorem and SOHCAHTOA. Well, I think angle C is easy. Angle C we should all know from geometry because why? Where you need to turn that in, honey? The angles of a triangle add up to 180. So if we've got a 49 and a 58, what does that leave me with? 63? 73? So angle C is 73 degrees. Okay, that's easy. Notice, by the way, that the sides, just like before when we talked about this, the sides are labeled across from their angles. So if this is angle C, this is side C. And I use capital letters for the angles and small letters for the sides. So this is side A over here. Okay, very important that we all are talking about the same thing. Side A is the side that's across from angle A. The law of sines is simply a proportion. In this problem, the law of sines says the sine of 58 is to 16 as the sine of 49 is to B. Very, very simply, the law of sines says the sine of A over A equals the sine of B over B equals the sine of C over C. That is very easy to derive. I'm not going to derive it because we have a lot of material to cover today, but it wasn't just made up. I mean, some smart guy didn't just make it up. You can derive it real easily from some regular right triangle trigonometry. So, all right, so you see where I got this? I said sine 58 over 16 equals sine 49 over B. Okay, is that solvable? Can I solve that? Yeah, how? Cross multiply. So B sine 58 equals 16 sine 49. So B sine 58, 16 sine 49. Divide by sine 58 because I am trying to figure out B. So 16 sine 49 divided by sine 58. And now I just go to my calculator. Make sure you're in degrees, obviously. These are degree measures. And I know the sine sound silly, but don't forget, the calculator's gonna pop a parentheses in here. Be sure you close that before you hit divided by. So 16 sine 49 divided by sine 58. And I got 14.24. Let's see if anybody else gets that.
I got that.
All right, so we're good to go. We're not done though, because we still need side C. Remember, don't even think Pythagorean theorem. Sometimes we think, oh, hey, I got two sides now, I'll use the Pythagorean theorem. No, we can't. So guess what we're going to do? We're going to do the same thing over again. We're going to say sine 58 is to 16. This time, we'll say sine 73 over C.
Do we always have to do like the sine A over A?
No, you don't, but it doesn't have to be A over A. But you don't want to be using this one unless you need to, because you rounded that off. So if you use it, you're automatically putting round off error in, and there's no need to. Now, later we'll look at a problem where there may be a need to do that, but right now there isn't. I'll just come back and use the one that doesn't have any round off in it. Okay, so we'll cross multiply again. So C sine 58 equals 16 sine 73. And our answer is going to be 16 sine 73 divided by the sine of 58. When I say it, it sounds so complicated, but would you agree it's pretty easy? So 16 sine 73 divided by sine 58. I got 18.04. You okay? You just solved your first triangle using the law of sines. All right, so now you're going to do one all by yourselves. Everybody okay? I'm going to erase this now. Anybody have a question about any of these numbers, where these things came from?
And that's always going to be the same for sine.
What do you mean?
Like sine's always going to be just like that.
Yeah, the law of sines is going to work this way. And I'm anticipating here a little bit, getting ahead of myself. But here's the key. In order to use the law of sines, notice that the law of sines, in order to set it up, there are four things, right? There's this and this and this and this, and one of them is a variable, and we cross multiply and solve. In order for it to work then, you have to have one complete match. That's right, you have to have A and A or B and B. So as soon as I see this right here, I know I'm going to do the law of sines. Remember, I have another option. It's called the law of cosines. We don't know it yet, but we have that other option. I'm never going to do law of cosines if I have this set. If I don't have a set, then I have to use the law of cosines. And that's a great observation. Okay, so here we go. Now we're going to try one. You're going to do it all by yourselves. Compare your answers with your neighbor. Make sure everybody's getting the same thing. And then we will look at the one potential difficulty with the law of sines. Okay, so we want to find angle P, side Q, and side R. Those are our variables. So would you jump in and do that? Do not look up here. Try to do it all by yourself. as you finish, look up here and tell me what you think about my answers as they compare to yours.
Did we get a new packet?
No, and I have one for you, but I'm not handing out with all these people I have, and it's too hard to keep track of.
I
So.
just making sure.
Yeah, no, you haven't lost it yet. And it's very small. Very small. All right, are we good on this? So if we were to take a little quizzy poo over this right here, we would all get it right. No issues. Okay, so now I'm going to throw that.
For the R lane. Oh, okay. I thought it was.
You got it?
Yep.
Now I'm going to throw just a tiny little wrench in, okay? Because there is one special situation with the law of sines that you just have to be alert to. It's not a huge issue, but you have to be aware of it. So let's look at an example of that. Now, think about what Anna and I were just talking about a minute ago. Is this going to be a law of sines problem? Yeah. We're going to say what? Sine 58 over 10 equals what?
Sine m over 11.
Sine m over 11. Now, is this a solvable equation? Absolutely. But it's a little bit different than the last couple we did. Because why? What was happening in the last couple?
Finding the side.
We're finding a side. Now we're going to find an angle. This is the special circumstance. When you are using the law of sines to find an angle in the first step of your problem, if that's how your problem begins, by using the law of sines to find an angle, your little antenna have to be up, because it might be that you have more than one answer to this question. This is called the ambiguous case. And referring you back to geometry, note the given is angle, side, side. And you remember from geometry that was problematic? Angle, 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 side, angle, side, all that was good. But angle, side made a bad word, remember? So you weren't allowed to use it. And the reason you weren't allowed to use it is it's called the ambiguous case. It might have two answers, and it might not. But you always got to check and see. So here's how that works. Let's go ahead and solve this. Just by regular cross multiplying, it says sine m equals 11 sine 58 over 10. So we just cross multiply like we always do. But when you type it in, you get a decimal, right? Okay, now keep in mind, that's not the angle. What is that decimal? What does that decimal equal? The sine of the angle. So how do we get from this number to the actual angle? You know how to do this. Second sine, that's right, special sign, second sine. So hit second sine, and then second answer. Okay, your answer button is your negative thing. And it should tell you that that angle is 68.88. So we type in our thing, our regular equation here. We get a decimal that represents the sign of the angle. So we second sign, second answer. The answer is your negative sign down there. That pulls that down for you. And then it says 68.88. Now, before you go any further, you know what you need to do. Once you have this angle, can you find that one? Yep, and once you have that one, can you find side N? Yep, but we're not going to do that yet. Because before we forget, we're going to check to see if a second triangle would be possible. If a second triangle with that given, that was the given, if a second triangle is possible, angle M, the second angle M, the first angle M came from your calculator. The second angle M will be the supplement of this one. What does it mean to be the supplement? Add up to 180. So I'm going to take 180 minus that guy, and this would be 111.12. 111.12. Now, you need to stand back and say to yourself, is that possible? Can I have a triangle with a 58 and 111? Is that okay? Yeah. This would not be okay. If this had been a 78, is it possible to have a 78 and 111? No. But it is possible to have a 58. So guess what? You've got that set of answers that are going to be possible, and you've got this one. So that set of information that I gave you created two separate triangles. This given creates two separate triangles, and we need to solve them both. So I'm going to go ahead and solve them both now, and then we'll do some more examples so you can figure out, okay, now wait a minute, what do I do? We'll figure that out. Let's back up. We set up the law of sines, solved it like always. This came out to be a decimal, so I had to second sign it to get the angle. That's how I get an angle on my calculator. I second sign or cosine or tangent. I got 68. I immediately said, okay, this is an ambiguous case problem. I'm finding an angle. Could I have a second angle? I find the second angle by simply taking 180 minus the first one. Either these work or they don't. In this case, they do. They're less than 180. So now I got to finish solving both triangles. So basically all that means is finding angle N and side N. So for the first triangle, what would angle N be? I'm focused up here now. Angle N would be
53.1.
You've already done it, 53.12. I'll take your word for it. Again, I'm focused here. I've got double work, but I got to stick with one at a time. How would I find side N now with this triangle right here? What could I set up to get side N? Sine 58 over 10 equals sine 53.12 over N. Would you agree? All right, so let's cross multiply and solve. I got 9.43, but double check me just to make sure. For angle, or for side N for the top triangle. Okay. Katie, what's the matter? Did you go look? This is how it needs to be set up. Is that how you have it? Yeah. Okay. So 10 sine 53.12 equals N sine 58. So you're going to divide this by sine 58. So this is what you need to be typing in on your calculator. Make sure you're closing that
So
parenthesis.
these are different because you're finding the angle.
All right. Now we got to repeat the process for this triangle. So we're going to do exactly the same thing. We're going to figure out what angle N is. It's going to be small. What is it? 10.88. Is that right?
Mm-hmm.
And now we need to find this side N. We're looking at this triangle now. So we'll say sine 58 over 10 equals sine 10.88 over N. We're looking at this triangle now, which had exactly the same given starting with, but turns out we have two possible answers. I got 2.23. Boy, that's a small number. Does it make sense that that would be a small number?
Yeah,
Because the angle's small. Yeah, it's called the hinge theorem from geometry, right? Got a big angle, then have a big side. Got a little angle, then have a little side. Okay, we were all feeling so positive because it was so easy, and then I threw this in there. Let's try a couple more. When is it I have to worry about this? Do I have to worry about this every time I do the law of sines? No, I only worry about it if I'm using the law of sines to find an angle. As long as I'm finding a side, it's like the ones we did at the beginning, right? That is easy. When I'm finding an angle, that's when I just have to be aware of the potential of a second answer. All right, so here we go. Let's say this angle is 52, this side's 12, and this side is 9. Now, we're not going to actually solve this now. You're just going to tell me how many triangles are possible. You can see I'm going to be solving for angle L. So I have the possibility of more than one answer. 2 is the most. You either have 1 or 2. Okay? Or sometimes none. We'll do an example of that too. Maybe this is one, I don't know. Let's see what happens. So sine L over 9 equals sine 52 over 12. Now, does everybody, even if you don't understand a word that's coming out of my mouth, you get that? All right, so let's find angle L. So we should all be able to do this. Type this in, remember, that isn't your answer. Don't be writing down the answer as 0.59. What is this number right here? What does it represent?
The sine.
The sine. So you need to second sign that number. And I got 36.23. Now, you could finish that triangle. Every single one of you, I know, could finish that triangle. You could find that angle, and then using that angle, you could find this side. But that wasn't what I asked you to do. I asked you to tell me how many triangles are possible. Clearly, this one's fine. If there is a second triangle, this is the given. This part is the same. That's not changing. But if there is a second triangle, angle L will be the supplement of the first angle L. So what would that be? Subtract 180. So 143.77. So if there's a second triangle, that's it. Well, look at it. Can that be? No, because you can't put a 143 in the same triangle with a 52. So that option doesn't work this time. And so how many triangles are possible? Just the first one. Just the first one.
Wait, what's the rule for?
They have to add up to 180. And more, I mean, all three angles have to add up to 180. Those are already more than 180, so it's going to be impossible for the angles to add up to 180. All right, let's try another one. Zach, what's your middle name?
Patrick.
How many triangles are possible? That's the question. In your homework in 5.5, there are some problems that say how many triangles are possible. All right, so here we go. Set it up like always. So what will the setup be? Okay, and everybody's going to be able to find sine P. Everybody's going to be able to find angle P. Eddie, what are you doing back there, honey? You got a calculator? Eddie. Okay, what happened? Yours said error. You know why it said error? Because that triangle's impossible. That set of data produces no triangles. The question was, how many triangles are possible? That configuration of information would not produce a triangle. Geometrically, what's happening is that side is not long enough to reach. So the picture actually would look like this. It's not long enough to reach to form the triangle, but the law of sines tells you that. This comes out with an error message. No triangle is possible. When you use the law of sines to find an angle, three things can happen. You can get one triangle, two triangles, or no triangles. So we've done an example of each. Now on your own, you're going to do an example of each. I'm not going to tell you which one's which, but with you and your partner, see if you can figure out, I'm going to put three triangles up here, see if you can figure out how many are possible. So we'll start with this one, and that's all you're doing is how many are possible. So there's your first set of data. How many triangles are possible? So you're definitely going to be setting up your law of sines. Gone ahead and drawn a second triangle just in case I need to check it. you're doing is telling me if there's 0, 1, or 2. 0, 1, or 2. So you don't have to solve the whole thing. Is that a bug?
Yeah, I killed it.
How we coming? I'm getting what I'm getting.
Yes.
Set up by law of sines. I wrote it up here. I didn't show all the different steps, but that's the setup I used. And I got 22.32. If there's a second answer, it would be 157.68. And supplemented at 180 minus that one. That didn't work. That's too much. So the only triangle that works is that one right there. And if I needed to solve it, that's the one I would solve. Find that angle and then find this side you'd be done. Over here, did all the stuff. I got 35.69, which means if there's a second answer, it'd be 144.31. And that actually would be okay. So this one has 2. And over here, I went ahead and set it all up, but when I second signed, I got an error message, which means the set of data I have is bad. Doesn't make a triangle. Everybody okay with that? Yeah, it's not hard. And you don't want to worry about it all the time. You worry about it when you set up an equation that looks like that, where that's your variable. That's when you have to worry about it. If your variable is down here, then it's not an issue. Okay? It's only an issue when you're going to have to second sign. Okay. All right, so let's look at the next triangle one. Katie, what's your middle name?
Tricia.
Patricia? Okay, so here we go. Let's suppose this is the given information. And your job is to find angle P, angle M, and side K. Remember, you're going to be given 3 pieces of information. There they are. And your job is to solve the triangle. And what's the first thing you notice?
The angle doesn't correspond.
The law of sines is not going to work. Now, it is absolutely true that sine 48 over K equals sine M over 10. That is a true statement. But I can't solve it because it has too many variables in it, right? So we are not going to be using the law of sines. We are going to be using the law of cosines. Now, the law of cosines is incredibly simple to use, but it looks so hard. I'm going to write it down for you, and then we're going to talk about it. K squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 48. I knew you'd be frightened of it. You do not need to be frightened of it. I want you just to write that down, and then we're going to talk about it. And I will give you the letters. The problem is, the letters, using letters means we have to have 3 versions of it. And what's important is you see the pattern, not the actual letters. They're not important, it's the pattern. So notice, there is one angle in the entire law. There's one angle, right? And there's one thing all by itself on this side of the equation. And the thing that's all by itself on this side of the equation corresponds to the angle in the equation. So if we are using angle K, which is the only angle we know, so of course we're using angle K, then the side that's over here all by itself is side K. Now all of this is what? What's this right here? What are these? Those are the other 2 sides, and they can be added in either order. So again, the letters aren't important. Add them in either order. Minus 2, that's part of the law. That's going to be in every one you do. So you're going to minus 2 times what?
The sides.
Those 2 sides again. Okay? So if I had triangle ABC, and I were using angle A, then I would say A squared, because that's the angle I'm going to use. A squared, and what would that equal? We're building the formula for you. What would that equal? B squared plus C squared, the other 2 sides, minus 2, that's always there, times B times C times the cosine of A. That's your law of cosines. Now the letters don't matter, it's the pattern that matters. Whatever is over here is what is here. And everything else is just squared plus squared minus 2 times sines. Alright, so let's go ahead and finish this problem. Your job was to solve this triangle. So you had to find the angle P, angle M, and side K. The law of cosines is going to give us what? What are we going to get out of this? We're going to get side K. So let's type it in. And the good news is you can just type that in. You don't have to do anything fancy. You just 10 squared plus 12 squared minus 2 times 10 times 12 times cosine 58 equals. Just type it in. Straight across just like you wrote it. Now, did you get 116?
You get 58 is 48.
Oh. Oh, I did 58? Oh my, I did, thank you. I'm old, I get to blame it on that and chemo and everything, you know, I got all kinds of excuses. Alright, you get 83?
Mm-hmm.
Now, that is not side K. That's K squared. Don't forget, you need to square root that answer. And I got 9.13. If I round it off to the nearest hundredth, is that what you got? The square root? When you use the law of cosines, remember this is squared. This is squared. It comes actually, the law of cosines can be derived from the Pythagorean theorem, so that's why it's got all these squares in it. Alright, now take a look at the scenario.
Okay, I'm getting something really weird.
Okay, well, I have to look at it. Just follow along with us now. We're going to finish this. Now, how am I going to find the rest of what I need? I now know side K. How am I going to find the rest of what I need now? Take a look at your situation. It's changed a little bit. Now we can use the law of sines, because what do we have now? Now we have our match. So we can say sine 48 over 9.13 equals sine m over 10.
Will this be the only time you'll use like a solid side?
No, we'll do it. We'll do it other times it'll be necessary, especially when we're finding the area. We'll use it, yeah. Here's the thing, Zach. If it wouldn't matter, as I continue with this problem, even if I were using the law of cosines to find the angle, which I could, notice all three sides are part of the formula. So even if I were using the law of cosines, I would still need to use that 9.13. It's going to be much easier for me just to use the law of sines. So, yeah, I appreciate you not wanting to do that, but we don't really have a choice this time, given that information. Okay, so we got angle M yet? 10 sine 48. Now remember, we're going to have the second sine, right? I got 54.48. Is that all right with everybody? And then angle P is going to be 77.52. How did I do that so fast? The angles add up to 180.
Do you not do the second triangle with this one?
Ah, is that what you were going to ask? Ah. Well, Mrs. Ford deliberately threw in one little comment earlier, and that was we have to be on the lookout for a second triangle when we use the law of sines to find an angle in the first step of the problem. Did I use the law of sines to find an angle? Yeah, but not in the first step of the problem. Here's the difference. The given information in this problem was this. In geometry terminology, that's side, angle, side. Did you have any issues with side, angle, side in geometry class? No. When you have the issues, kids, is when your information is angle, side, side. So the answer is no. I don't have to worry about it. I have a unique triangle. I need to be worried. Actually, not worried makes it sound negative. I need to check for a second triangle if I am using the law of sines to find an angle in the first step of the problem. If that's how I jump in and begin, then that means I have an angle side side situation and I need to double check. If I have a side angle side or a side 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 or something like that, I'm not going to worry. Now, could you check for a second triangle? Yes, but it will never work. So you don't have to. But if you want to, if it just is consistent for you and you want to check, absolutely. Go ahead. Okay? All right. Now, let's try another one. How about this one? Hempelman, what's your middle name? Alright, so let's try 10, 12, 14. Oh my, this is different. This time, when we know all the sides, we're finding angle O, angle H, and angle M. Your two tools that you have are law of sines and law of cosines. Between the two of those, you will be able to solve every triangle I throw at you. So which one is going to be used in this problem? Sines or cosines? It's got to be cosines, because in order to use the sine law, what do we have to have? Angle O and side O. We don't have it. Angle H and side H. We don't have it. Angle M and side M. We don't have it. So this is going to be a law of cosines problem. Okay? Now, which angle do you want to find first? Let me ask it the way it'll be asked on a quiz. Find the smallest angle of the triangle. So you got to look at that and figure out, which one will be the smallest angle of the triangle? H. Why is H the smallest angle? Because H is the smallest side. So we're going to find angle H. In reality, you can find any of them first. It makes zero difference. But just so we're all finding the same one, let's find H. Okay, so I'm going to set up the law of cosines, and I'm using angle H. So in my equation, there's one thing here, and there's a whole bunch over here. What's the one thing that's going to be here if I am finding angle H? 10 squared. So this is going to say 10 squared. If you are finding angle H, then this is side H. Now, what goes here and here? 14 squared plus 12 squared. One side's over here by itself, and then the other two are here, right? Minus, always minus, and always 2 times 14 times 12 cosine H. So, this one's a little harder to type in. Not hard, but you got to be careful because you're tempted to make some dumb moves. So let's go ahead and do some multiplying. So we got 100, we got 196, we got 144, and then we've got, I don't know, 2 times 14 times 12. What is that? 336 cosine H. So I just squared that and squared that and squared that and multiplied those three things together. Is that okay with everybody? Now, can these two be added? All right, so let's add it. So 100 equals 340 minus 336 cosine H. Here's the place where we make mistakes. Can these two be subtracted? No, no, they are not like terms. This one has a cosine hook to it. These are separate. You cannot put them together. So what are you going to do to continue solving? Subtract. So you're going to have negative 240 equals negative 336 cosine H. So cosine H equals 240 over 336. What do I do with that? Second cosine it. Very good. You want an angle? You got a second something. Obviously, it's a cosine problem, so I'm going to second cosine. And that angle is 44.42. That was angle H, 44.42. Is that what you got? So if indeed the question said find the smallest angle, you'd be done. You found it. If you were actually solving the whole triangle, what would be your next step? Law of sines. Because now you can pair these up, right? Now, this is an example, Zach, where I'm perfectly cool with that. But if you didn't want to use that answer, could you do what we just did, but find angle O, let's say, instead? Yeah, you could do the law of cosines again if you wanted to for angle O.
I think so. Yeah, it's just.
Or you can use the law of sines. I don't care which one you do. Everybody good with that? All right, I'm going to give you a law of cosines problem to do by yourself. Check your answer with your partner. Make sure everybody's got it figured out, how it works. Actually, I think I'm going to give you two, one of each kind. One where you find the side and one where you find an angle. Alright. Caitlin, what's your middle name?
Well,
Alright, let's say this is 71, 15, 17. Find side R. Alright, there's your first problem. Find side R. Anna, what's your middle name?
Victoria.
And in that second one, I want you to find angle A. So you're going to use your law of cosines both times. These are both law of cosines problems. And you're just going to find what I asked you to find. You're not solving the whole triangle. You're just finding one piece of it. match? Do you match me?
Yes.
Be really careful as you're, this one's pretty straightforward when you type it in, but just watch your typing on that one over there. Make sure you're doing stuff in the right order. It's a little bit harder. Any issues? No question, everybody's got this figured out?
Yep.
All right, let's look at both problems real quick. If you had been asked, and you weren't, but if you had been asked, let's say, to solve this triangle, remember what that means. That means find everything that's missing. So not only would you need side R, but you would also need angle K and angle C. Once you figured out that this was side R, then you would have this set and you could jump in and use your law of sines to find one of the angles, right? And once you found that, like let's say you found K, then you could just subtract from 180 to get C. Everybody understand what I'm saying? Okay. So here's what we're going to do now. Let's put everything away. Set a piece of paper and our calculators.
Oh no.
And does anyone in here have a birthday on the 9th of the month?
The what?
Then you're at the board. Here we go. Alright, so this is a quiz that we are all working on together, and Sam is in the hot seat because she's going to do it, and you're all going to do it. And just like you check me or we make sure we're matching, you're going to want to match her. And we have 3 chances to get it right. So if Sam, well, first of all, let's just assume positive. You're all going to agree with Sam. We're done. It's perfect paper. Or you don't disagree with Sam. We have 3 chances to help her figure it out. All right? So here we go. Here's the problem. Here's the problem. Now, everybody's doing it. So, Effie, I'm going to come back there with some scissors and I'm going to chop that hair off. All right, now quit playing with it and focus. We are all doing this problem, all right? Here it is. What's your middle name, Samantha?
Abigail.
Okay, so here it is. So this is going to be 54. This is going to be 77, and this is going to be 73. And your job is to solve the triangle. So that means you are finding side M, angle S, and angle A. All right, and we're all doing it. No talking. When we're done, when she's done, we'll have a chance to either agree or disagree with her. But right now, we are all doing the problem. that degree does not show up on the video,
Yeah.
so I wanna make sure whoever's watching this can see what the answers are. Okay, we either are gonna agree, we're either gonna agree right now, everybody's gonna agree, or we're going to have to coach her a little bit, so.
She's right.
Well, she's right?
She's right.
Everybody's agreeing? She's
Yeah.
right?
Go Sam.
She's amazing. Go Sam. Alright, she is right, you're right, so you all get a perfect paper. Okay. So, what we need to do now is go ahead and begin your 5-5 or 5-6 homework. You can't do all of 5-6 yet because we haven't done area. We'll do area on Friday, or tomorrow's Friday, I guess Monday. We'll do area on Monday.